I now want to talk to you about the digital signatures assignment. So the assignment is here, and you can, as usually, find this on the enclosed PDF file. And let's quickly go through the lecture preview to understand what we need to know in order to do this particular assignment. So the way public-private key infrastructure works is every participant has a public-private key pair, a public key and a private key. The private key is private, only the participant knows it, and the public key is public. Now, what the public key encrypts, the private key decrypts. So, anyone who wants to send an encrypted message to this person uses the public key to encrypt the message, and only the person with the private key can decrypt it. It also works the other way around, at least for RSA keys. And the way this works is if it has been encrypted with a private key, then everyone can decrypt it with a public key. And this is useful for signatures. So the way this works is the sender has some clear text, and they calculate the hash just because it's easier, and then the hash is encrypted with the private key. And then this encrypted hash is then forwarded to the recipient. The recipient can use the public key to decrypt it, and they get back the hash that was obtained by encryption. And so they know the only way that this could have done is with the private key. At the same time, they have the clear text that has been signed, and they can calculate the hash of this clear text. And then they simply need to compare the two hashes, and if they coincide, then it knows that the person who signed it needs to have had access to the private key. So this is how this works. So now let's look at the exercise. So before we look at the exercise, let's actually have a look how we can calculate this in practice. So let's first generate a bit of lorem ipsum here. So here we generated one paragraph as lorem ipsum. Let's copy this one, and let's go to our favorite agwifi.org, and we can just say generate signature. We paste it here, and now we have here our signature that has been generated, and that is a public key that has been used for the signature. Now it's important to keep both, because to verify you need the public key and you need the signature. You do not need the private key. You obviously also need the message. So let's go here. So what I have here is a previous session. So think about this as being Slack. So this is something now I want to verify. Someone posted this onto Slack. So I go here. It says verify signature, as you can see here. So I paste my public key here, and I paste my signature here. Okay, and now all that is left is to paste the message. And let's see whether this one works. And no, signature verification failed. So I hope it's the other one. So let's copy this one. We copy this one. And signature verification passed. So we know that this top message corresponds to this public key and to this signature. All right, going back to this assignment. So what you should do is you should create some text, and then so you can do this with libsyn.com, or you can write something, and you digitally sign it over at ec-sign-verify-jsp at agwifi.org. And then on Slack, you publish the text, a modified version of the text, the signature, and the public key. All those goes on Slack. And then someone else uses, again, agverify.org to check whether or not, or rather which of the texts has the correct signature. So deliverable is one paragraph on the experience as usual, but also there's a question in today's assignment. And the question is essentially about, well, hashes kind of did the same thing. So I would like you to think about a little bit about how hashes and signatures are similar or not similar in the context that we have been using here.